Good afternoon, everyone. Welcome on behalf of the Washington Stormwater Center. I would like to introduce our Context and Applications Permeable Pavement webinar. Our speakers today are Curtis Hinman from Herrera Environmental Consultants, Jessica Knickerbocker from the City of Tacoma, Ken Pierce from Washington Fish and Wildlife, Don Anderson from Pierce County, and Jen McIntyre from Washington State University. And at this point, I'm going to hand off the presentation to Curtis Hinman. Thank you very much.
Great, thanks, and welcome everyone. I think my job today is to get us started with some context, the application of low-impact development, in particular, of course, permeable pavement, and then some background on permeable pavement systems. And for those of you joining us from other parts of the country or perhaps the world, we're going to be talking from the context of Pacific Northwest United States. There are some unique drivers as well as drivers for the application of low-impact development and permeable pavement in this part of the world that are not necessarily unique. Other states face some of these same regulations, but there are some unique drivers in our part of the world. First of all, many of the states in the United States, all actually, facing National Pollution Discharge Elimination System permit requirements, just like Washington State. But in the Puget Sound region, we are a priority estuary, so there's additional attention to this region because of that designation. Layer on top of that endangered species listings within a major metropolitan area. If you put that all together, you have a lot of attention going towards stormwater management and how to better manage the impacts of urbanization to our receiving waters. So again, to sort of start off, we'll talk a little bit about low-impact development principles and practices. And again, this is really from the perspective of our region, but much of this you see adopted or applied in other parts of the country. First and foremost for us, low-impact development is a land use development strategy that emphasizes the protection and use of on-site natural features to manage stormwater. And that we know in our part of the world and other parts of the world as well that our native vegetation and soils are our most effective stormwater management tool. They're the most cost-effective stormwater management tool as well. Once you've done everything you can in planning and protection of those on-site natural features, then there are the integrated, engineered small-scale stormwater controls. And this is the fun stuff, right? The bioretention, vegetated roofs, rainwater collection systems, and one of the very important applications, permeable pavement, our subject today. We have generally thought of, and I think many parts of the country have thought of the use or the application of low-impact development at the parcel and subdivision scale. That's necessary but not sufficient. There is a good body of research in this region as well as other parts of the country suggesting that you also have to think at the regional scale. That is, where and what of development are you placing on the landscape? For example, overall road network density can be a very strong driver as far as receiving water health. So both of those are critical, site scale and regional watershed level planning. For us, a primary goal, this is not codified, but a primary goal that we aspire to for low impact development in this region, no measurable impacts to receiving waters. As you can imagine, that can be very difficult in an ultra-urban setting, and that is not necessarily a goal that we set for, say, downtown Seattle or an ultra-urban setting, but in greenfield development, and particularly with sensitive receiving waters, no measurable impacts to receiving waters in our part of the world means that you essentially are managing all stormwater on site. Now I'm speaking generally, there's a lot of detail in that embedded in the regulation, but generally for sensitive receiving waters, greenfield development, we are often managing all water on site. And we do that by maintaining or more closely approximating pre-development surface flow volumes and durations. Okay. So what are some of the practices? Well, bioretention, such as this bioretention swale located in West Seattle, the High Point neighborhood. Vegetated roofs. It's a beautiful roof here on what was the Washington Mutual Tower, I don't know what it is now. It could be, perhaps it's the Chase Tower now. One of the lesser known low impact development applications, low impact or minimal excavation foundations that use pin piles for the support, so there is much less soil disturbance and compaction. Rainwater harvesting, rainwater collection systems, such as this system here on San Juan Island. And of course, in our subject today, permeable pavement. And this is a great shot from Mukilteo Lighthouse, permeable pavers. All right, so a little bit of history on permeable pavement. Actually, pervious concrete has been used for quite a while for various applications. 1800s in Europe for pavement surfacing and load-bearing walls. 1920s in homes in Scotland and England. And a primary driver for the early use of pervious concrete was cost and scarcity of the cement, how to reduce the use of the cement within the concrete. For porous asphalt, originally developed in the 1970s. You can see here a picture on the top left. One of the first applications in the United States at Walden Pond, 1977. Haven't been out there recently, but I understand that installation is still working well. And the Franklin Institute in Philadelphia, Pennsylvania was really one of the first groups to conduct initial development and research on porous asphalt. Porous asphalt has also been used for open graded friction courses. That is essentially porous asphalt on top of, often 2 inches of porous asphalt on top of conventional densely graded asphalt. And there's a picture here you can see on the lower left with conventional asphalt paving on the right set of lanes and the open graded friction course on the left. And this is primarily used for safety. So as you can see, reducing spray, improving visibility, also noise reduction. And notice this quite often at porous asphalt and pervious concrete installations. When they're wet, they are quite a bit quieter than conventional pavement. So that's a little history. What are some of the applications? There's quite a few. Parking, sidewalks, plazas and patios, sports courts, noise barriers and walls, low volume residential roads. And here's a few pictures. You can see a bicycle lane in Bellingham, Washington, northern Washington State and northwest Washington State, Marysville, park and ride, and a sidewalk in Seattle. However, permeable pavement has been used successfully on high-capacity roads, and in this case, porous asphalt applied on a highway in Arizona. And the porous asphalt on the right, densely graded conventional asphalt on the left. The last check on this system was still working well, and up to, I believe this installation is now 10, 12 years old. So what are some of the opportunities? So why use permeable pavement and some of the challenges? First, I think and foremost, these are systems that are dispersed infiltration facilities. And we have constructed, installed, and measured the use of permeable pavement on very poor soils and able to infiltrate the water that falls on that system quite effectively, even with very poor soils. So that dispersed infiltration provides quite an advantage, particularly for when you're trying to manage stormwater on poor soils. Research from Europe and the United States suggesting that there's very good water quality treatment within permeable pavement systems for metals, hydrocarbons, and even nutrients. It's a well-proven technology. Permeable pavers, for example, have been tested and retested, and the technology is very well established. Pervious concrete, certainly in this part of the region, we have very good specifications for that. Other parts of the country as well. Porous asphalt has lagged behind a bit in our part of the world as far as solid specifications, but that is changing rapidly. We now have recently developed good, very solid specifications for porous asphalt. There are, however, some challenges, certainly, and this is a somewhat new technology and application. And so we have construction challenges, that is training construction equipment operators and construction foremen how to place these systems. We've, for example, been telling people, all their equipment operators, all their operating lives, to basically compact subgrades to rock hard, and now we're telling them, no, 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 we want this to be fluffy and infiltrate water. So this is a big change, and it's going to take a while to get region trained on proper construction of these facilities, and we should expect to need to spend a bit more time with the construction operators to get them up to speed. And maintenance, all stormwater facilities need to be maintained, and permeable pavement systems are no different. And so this is something we have to, as a region, start to adopt good maintenance programs for these systems. A little bit on the components and their functions. There's the wearing course, or the top course, that may provide, in the case of pervious concrete, being a rigid system, structural support. Should always be an overflow. And in this case, in the picture you see on the slide, there is an open aggregate bed in front of the car that, in case there's any clogging, water can flow into that aggregate bed into the aggregate base underneath the pavement. So there should always be an overflow, and there are many different ways to design overflow systems. Then you have a leveling or choker course, not necessarily needed with pervious concrete, but with your pavers and asphalt. There's often a leveling or choker course. The aggregate base storage course, this is for flexible systems. Critical is for structural stability, but also this is where water is stored and then moves into the subgrade. So it serves both as a storage and a structural component to the system, and in particular for the flexible pavement systems. There are almost always under or elevated drains. Elevated drain is a particularly good way to manage water in these systems, in that there can be then slow if the subgrade is not very permeable, or there is low infiltration rates. Water beneath the elevated drain can then slowly move into that subgrade, but the elevated drain provides a safety overflow during larger storms. Subgrade berms or trenches can be used and are used for sloped areas to slow and manage water on slope. Geosynthetics, we generally do not recommend geosynthetics on the bottom of permeable pavement system unless it's for strength. Often geosynthetics will be used on the sidewalls, particularly if you are trying to restrict infiltration to adjacent infrastructure. And then the native underlying soil, and of course a critical component of the system. And this is where we are learning a lot and having to change our construction practices to develop that subgrade so that it is structurally sound, provides a structural subgrade, but also is still permeable. Okay, some of the critical design and construction factors. Site assessment. Going back to the subgrade, we are asking more from the subgrade in the permeable pavement systems, not only to provide adequate structure to the system, but also to remain permeable. To do that, you need to have a good information, a good sense of your site soil conditions. And so this is a critical part in the application of low impact development in general, and in particular permeable pavements. You have to have good site assessment to understand your site soil conditions, correct design specifications. We're getting better and better with those design specifications. Qualified installers. And again, we have a ways to go getting a region and really the nation trained up on the use of these new low impact development practices, and certainly with permeable pavements. So we expect the need and continued work with training people who are installing these systems. Fortunately, there are already some good programs in place with pervious concrete and permeable pavers. Already good training programs in place for those two systems. And of course, erosion and sediment control to protect the subgrade so it remains permeable, as well as the top or wearing course. And then maintenance. And again, this is something that we have work to do on this area, as far as making sure that there are good maintenance programs in place and that they are actually carried out. And I think that is the key there, making sure they are actually implemented. Finally, to queue up the next speaker, fundamentally there are two types of permeable pavements. Rigid, which would be the pervious concrete system, and flexible, all the other systems, porous asphalt, permeable pavers, and grid systems. All of these systems rely on proper subgrade preparation and aggregate base design, critical for all systems. However, proper subgrade preparation and aggregate base designs are critical structural elements for the flexible systems. That aggregate base design is the structural support for those flexible systems. And so the proper aggregate, the proper depth of aggregate, and the proper preparation of the subgrade and that aggregate are critical for long-term structural success of these systems. So with that, I'll end the presentation and open to any questions.
First question is from Craig about how does design account for secondary compaction caused by traffic loading?
Well, Craig, if I understand the question correctly, you're perhaps focused on the wearing course. I'll address this from both or all three components really: subgrade, aggregate base, and then the wearing course. Again, for the rigid system for pervious concrete, load bearing is design, and load bearing for pervious concrete is well established, and primarily the load bearing is dealt with the thickness. So as far as the need for increased load bearing is dealt primarily with your thickness of the concrete wearing course. The aggregate base, and to some degree the subgrade, is a bit less important with the rigid systems. Nevertheless, subgrade preparation and aggregate base is still important. And for the flexible systems, it's critical. So you deal with that load-bearing need through proper subgrade preparation. And fortunately, we have new specifications coming out, or guidelines, I shouldn't say specifications, but guidelines on proper subgrade preparation and aggregate base. So that's primarily dealt with the correct type of rock that will lock together properly. It should be an aggregate base comprised of rock with a 90% fractured face, providing a rock that will lock together very well at the proper depth. And then your wearing course is, for pavers, for example, very stable, very strong paver, relying on that aggregate base for the structure. So hopefully that answered the question. There's a lot of similar type considerations for the permeable systems as with the conventional paving systems. However, a big difference is in that aggregate base design and construction for the flexible systems. So next question.
Leroy has two questions.
Leroy asks a question that's actually quite complicated, but I'll try to answer it quickly because it's a very important one, and that is, what is the balance between not compacting the subgrade as much versus settlement? This is a critical question, and this is where you have to work closely with your geotech and with your construction operators. But we have debated now for years on the proper verification of subgrade compaction, and is that something that can be left up to, or can be decided, for example, by firm and unyielding, that is driving a certain weight truck over the subgrade and seeing how it reacts, or doing a particular density test. And so this is something you have to work with your geotech closely, and then work with your construction people closely to make sure that it's properly implemented. There's a lot of detail in here that we can't get into, but there are better and better guidelines. The Low Impact Development Guidance Manual provides some good guidance on how to construct these subgrades without overcompaction. And I will say, in some cases, when you open up an undisturbed subgrade, there may be no compaction necessary to provide adequate subgrade support. And as important as proper compaction or not compacting is the consistency of that subgrade. That is critical. In other words, if there are big differences in the soil type and how that soil type is behaving under load, or might behave under load, that has to be accounted for. Okay, so I'll take one more, and that is methods used for maintenance of different permeable pavements. Generally, if regular maintenance, for example, once a year or twice a year with true vac, so that would be a high volume vacuum, or high quality, high volume vacuum with a brush, doing that annually or biannually. But if you get to a point to where it's clogged, where infiltration is reduced to a point to where you need to clean it, and there are guidelines about that are, again, coming out soon, or out already, you really have to use a pressure wash system with vacuum. And there are new tools coming online for that. For example, Paragon has a system, and others are now working on developing systems that will clean pavement that is badly clogged. So that's a quick overview of maintenance techniques.